All right, for the solar eclipses, guys, this one's really interesting. Probably my favorite one. You guys need to explain how solar eclipses work, right? So this is my moon. I'm using a different size of a moon because that one's too big over there. And I need my moon to cover up the sun. So you guys will be explaining what's happening when you have a full solar eclipse. So you kind of have to play around with the distance of your moon depending on where you're standing or sitting until it covers up your sun. That would be a full solar eclipse. So a full solar eclipse is something like that, somewhere around there, where the sun is kind of glimmering off to the sides of the moon. And then you have your annular eclipse. Your annular eclipse is a little bit when the moon is a little bit further from the earth, closer to the sun. So this would be an annular eclipse right there. That would be an annular eclipse. And then your partial eclipse would be something like that, where the moon is covering only part of the sun. So you guys need to explain what's happening in each of those three right there. And that's all you have to do if you have a physical model. Just explain what's happening with these solar eclipses. With the lunar eclipses, guys, that one's a little bit more difficult to show with a physical model. So you guys can make a drawing for the lunar eclipses. So the lunar eclipses would pretty much have to be back here. And then, it's kind of hard to simulate that with my shadow because the moon is located behind the earth, behind its shadow on the umbra. So it's a little bit difficult to explain this one right here. You can't really see any difference right there. So I won't have you guys explain this one with a physical model. You can explain it with a drawing, with a diagram.